No, sir.
Okay. Okay, so here we go. We have to discuss the topic of electromagnetic spectrum, I believe so. Uh, yes, Zainab, welcome. Are you Zainab? Uh,
Zanabahab.
Zainab Awab, Wahab, sorry. मेरे पास दो जैनब है ना, तो फिर मुझे कंफ्यूजन हो जाती है। पहले वाली जैनब गायब होगी तो एक दूसरी का जैनब भी हमारे पास आ गई है। दिस इज वेरी यूनिक आइडिया। ओके जी, बिस्मिल्लाहिर्रहमानिर्रहीम। इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम में the things what we have to discuss, they are the dispersion of the light specifically I have discussed, so it would not take much more time. Then application of the electromagnetic waves, this is the area what I have to discuss with you in detail. So when we talk about the dispersion of the light, actually when the light falls on a prism, what happens, it is dispersed, it is split into seven colors. So you people are asked what is mean by dispersion of light. So dispersion of the light is splitting of the light into seven colors. So here we go, that these seven colors have a sequence, and the reason for the for this dispersion is mentioned above. Every color has different wavelength, and the thickness of your prism is different at different portions. That is why its refractive index is, yani, due to thickness it is changed, and when it is changed then it bends the light at different angles, right? So that causes the waves to be split up. White light is now converted into seven colors, and sequence is Vibgyor, right? So dispersion effect narrows. Each color from the original beam of the light has its own particular wavelength, I told you, and each wavelength is slowed down at a different level in the glass. That's why this all happens. So here is the important thing. For example, if you are going to incident the blue light, here the blue light would be dispersed at this angle, and the red would disperse small at the smaller angle than the original path. This is the original path. The light must, yani the light had to go in this direction, but as a light has been dispersed, sorry, it has been bent, so it is moving in this path. अब देखो, the problem is inside the prism. Last time I told you that inside the prism and outside the prism you have to draw two lines, and these two lines must follow the pattern of Vibgyor, that the light, yani that color of the light which has larger frequency or highest frequency, it would bend more. So just simply consider one thing, that bending is directly proportional to frequency or inversely proportional to wavelength. Both concepts are equally helpful. So I believe so that if you are able to know about the game of V I B G Y O R, that is what, that is a sequence of increasing frequency, right? It is increasing frequency and decreasing wavelength, decreasing wavelength. So as the wavelength decreases, bending increases. That's why violet bends the most than that of the red. Then this is the basic electromagnetic wave mechanism, that in electromagnetic wave we have the fields, electric field and magnetic field, rather than the particles vibration. That's why these all electromagnetic waves have no need of the medium. So electric field can be produced even without medium, and magnetic field also. So these fields can be propagated in vacuum as well. So that is why the electric and magnetic field are perpendicular to each other. So just simply consider one thing, that the magnetic field and electric field are perpendicular, as well as they are perpendicular to the direction of propagation of the wave. So this is the behavior of all electromagnetic waves. So there are some common features. This question is frequently asked, that what is common in all electromagnetic waves. So all electromagnetic waves are transverse waves. All electromagnetic waves can travel through vacuum. They travel at the same speeds as the speed of light. They all have the properties of reflection and refraction, and they all obey the equation of V is equals to F lambda. And the shorter wavelength would have highest frequency, and the frequency gets higher and energy increase. This is a extended variant concept, no need to write it down all the ways. This is the most important five features. So I think they are very easy to remember, isn't it?
Yes.
Okay. So moving onward, I told you to go to the properties of the electromagnetic spectrum. Some radio waves, microwaves, infrared. Actually, this is what I have to tell you about the electromagnetic spectrum. So, who will tell me about the structure of electromagnetic spectrum? Yes, hurry up. Yes, no one. Did you ever heard this mnemonics Jexulimer? That G stands for gamma rays, X stands for X rays, U stands for ultraviolet, L stands for visible light, I stands for infrared, M stands for microwaves, and R stands for radio waves. Is it?
Yes.
You have to keep all these points in your mind as a sequence of this. This is really, really important. The sequence is very important. You people are asked about that. That which block, yani which segment is missing from the given set of the blocks. So you must now GXULIMR. So I told you what does it mean by G, what does it mean by X, and so on. All these are the part of electromagnetic spectrum. So that is why radio wave, microwave, infrared radiation, visible light. So this is the R and E. This is your R. Jaxulimer mein R is there. Are you seeing? Do you see that? R M I R V. Yani visible light is basically L, and then U, and then X, and then G. So each type of radiation produced by the detection by the special ways. Yani you cannot see all these. Do you see all these lights? Yani all these electromagnetic rays? Never. We have a range. Yani we have a limitation that we can only respond to a wave of yani to 400 to 700 nanometer, which can be seen by human eye. Rest all would be detected by different detectors, and detectors nature depends upon the nature of the electromagnetic. Higher frequency of oscillation are the greater energy changes, that the shorter wavelength of the electromagnetic waves. Yani this is actually a game of yani if I talk about the energy of the waves, that the energy of the waves is directly proportional to frequency. That is why gamma rays are the most energetic. Do you know? Gamma rays are most energetic, and radio waves are least energetic. So here a pattern is visible to you, and this is just an idea about their uses. The gamma rays, they are very dangerous and just used for gamma therapy or radiotherapy. Then X-rays for the bone scan, ultraviolet ultraviolet lamps and tanning of the leather, and then visible light for all visible impacts, and then microwave, infrared, and microwave just heating and thermal radiations, and microwave also. For they are used for communication also, and then radio waves, they are used for communication. So these all are different aspects of your radio waves. Now I will talk about application areas one by one. Um, Question is asked from here, right? So please keep all these informations with you. This all is information. I'm just going to uh, float this information to you, that the family of radio waves, radio waves are used for communication. I will just summarize one use after all these discussions, that what is the use of radio waves. Radio waves are used for communication at uh, for your radio and television broadcast. So simply you will simply say that radio and TV communication. Okay.
Okay.
Sometimes you can also write as mobile communication, because mobile communicates in two ranges. One, in the upper range of the radio waves and lower range of microwaves, right? So this all is mentioned here: radio waves, then FM is just a radio, definitely, and then the television and frequency, radio wave, I mean telephone. Then satellite communication on TV, they are performed by your microwave. So all wireless communication is basically done by microwaves UED, wireless communication, right? These are the one use, yani which can be written as a single use. जब आपसे ये पूछेगा कि write one use of microwave, so you can use this one, right? Is it clear to you? Or you can say the radar communication. Radar communication. Is it clear to all?
Yes.
So yeah, this is
Yes.
mentioned here. The radar systems are using microwaves. Then microwave ovens are using for microwaves for cooking, right? So these are basic fundamental uses, I believe, so that you are aware of this all. Then uh, RAN disturbs satellite TV. That is basically because microwaves are having the effect of the RAN. Sorry, RAN affects the microwaves because they have more dispersion. That is why it happens. So satellite, it is mentioned here that satellite TV uses the electromagnetic frequencies in the microwave region. They are strongly absorbed by water. This is very interesting fact, that microwaves are absorbed by water. That is why you are able to perform cooking. It is not like they perform cooking, they just cook food. Actually they break the bonds of your water, so they absorb the water, right? And RAN reduces the strength of the signals, and when it reduces the strength of the signal, but broadcast minimizes the uplink mean uploading is just decreased, and downloading is okay, fine, it does not matter. So that is why when you see the internet, most of the time uploading is greater than, sorry, downloading is greater than uploading. So this happens in our daily life, I mean on daily basis. Then we have infrared radiations. They are just used for the heating, as the heaters. Infrared radiations are used for remote controls, right? They are the radiations of the radiant heaters, infrared radiations, thermal radiations, and then remote controls. I think in the next slide it will be, right? Then remote controls of everything that is using the IR spectrum. And yes, one advantage is being asked to you. I think that we will talk to that advantage and disadvantages of using different type of radio waves. Then intruder alarms are there are some sensors, and then they use infrareds because they cannot see them. But once they cut the lights, sorry, cut the wave, what happens? The alarm is being operated. So they are actually used in security alarm systems. Then for optical fiber, we use infrared and visible light, both. ऑप्टिकल फाइबर में इंफ्रारेड यूज होता है फॉर इंटरनेट कम्युनिकेशन, and light is used for endoscope and other type of medical instruments. They are used to see the inner structure of your yani stomach and intestine. So that is endoscope. That is a flexible fiber optics, or fiber optics, yes, that is the word which I have used for infrared radiations for internet communication. And internal cavities can be viewed from that. Endoscope is very common, you know. This is a technique, medical technique. Endoscopy. We usually called it endoscopy. Then optical fiber. Optical fiber is basically a sort of uh, application of your visible light as well as your IR. I told you about that. So telephone communication, network communication, or something like that, it is being done by your optical fiber signals. So this is one of the use of that. Then you have to take care of the ultraviolet radiations. The skin cancer is basically caused by the ultraviolet, but there are some uses of ultraviolet radiations. They are just turning they actually affect the skin. Darker skin absorb more ultraviolet light, so less ultraviolet radiation reaches to the deeper tissues, right? So ultraviolet radiations can cause normal cells to become cancerous cells. So this is one of the uh, sunbed, you can say. This is one of the use of the ultraviolet. Then the fluorescent
Sir,
tubes. Yes,
but we also use UV rays to treat cancers.
yes, we use, but
So
they
like,
are the reason of the cancer as well.
so is that because of different intensities or something?
Yes, actually different ultra, yani low intensity, low frequency ultraviolet, they are used to create the treatment.
Uh huh.
Sorry, sorry, low frequency are used to create the cancer cells, and high frequency are used to damage them, yani to destroy them.
Oh,
Okay.
okay, got it.
So fluorescent lamps inside the tubes, they are coated, and basically which gives off the light when absorbed. The ultraviolet is produced by passing an electrical current. So here we use the ultraviolet signal. Uh, Actually, these are the mercury lamps, mercury tubes, right? Mercury vapors. So there are so many things. Ultraviolet used to sterilize the equipments like that can be used to sterilize the bacteria and virus, etc., etc. So here the medical use of the x-ray is just to perform the bone scan, right? Because they can pass through the skin, soft tissues, and they are bounced back from the hard tissues like bones. That's why when they reflect back or when they are absorbed, we can see that the x-rays are used to scan the bone. Do you see some difference here? There is basically the soft tissues. These are the hard tissues, but these are the hard metals. So as the material is getting more rigid or more hard structure, then it shape or the contrast appears more clear. So the this is detected by your x-ray paper, and x-ray paper is basically that paper at which the x-rays are being uh, x-rays are regenerated. Then radiation treatment is performed by high radiation x-rays, high frequency x-rays, as well as low frequency gamma radiation. So x-rays are also used for the treatment to destroy the growth of the tumorous cells, right? And as well as the treatment of leukemia. It is a sort of blood cancer. Then detecting the cracks in the metals, it is one of the use which is being which is most appropriate to find out the cracks in your metals, like the metals used in the aeroplane structure, metals used in the heavy machinery. Those cracks which cannot be seen you cannot see these cracks ordinarily, right? But you have to open this up all. So when you perform x-rays, the x-ray will tell you that yeah, there are some cracks inside. Then there is another use of the x-rays. Yes, that is the security scan. What is the security scan? When you go to the aeroplanes, sorry, to the airports, your bags are scanned. So they are actually x-rays. X-ray treatment are being performed for the bags. उसके बाद आपके पास आता है radiation therapy for the gamma radiation. Gamma radiations have different uses. For example, this is just a gamma knife or a sort of structure where the patient is treated for gamma therapy, right? Gamma rays damage the cells whether they are normal or cancerous. So they do not know the cells are normal or cancerous cells. That is why we try to just prevent rest of the cells, but it is very difficult. That's why a wide beam of the gamma rays are rotated around the patient, keeping the tumor at the center. So this concentrates the gamma rays on the cell. Yani, actually, this is what, this is a sort of converging lens for gamma rays, right? So all of the gamma rays would be converged and they will just reach to this point. In this way, those cells are being uh, uh, treated. And detecting the cracks, that is also for gamma therapy, but the deep metals, not for the ordinary metal levels. Those metals which have the emulsion over them, just like the ship has very thick layer of paint and emulsion. That's why it is not possible for the x-rays to reach deep into. So they are treated with gamma therapy or gamma radiations. So this is basically the use. Then here we have another list, yani shorted list of all the radiations, their wavelength range, and their uses. So please, this is the slide you have to recall finally. This is the final recalling slide. Will you be able to do that?
इससे इनकी wavelengths याद करनी है.
No. For your level, it is not asked.
Okay. Only
For
using.
AS, yeah, only uses. For
Okay.
AS, we have to use these wavelengths as well. We have to recall the wavelengths. Okay?
Okay. सही है.
Okay. Now we have all of the questions here. So yes, this is the question which is to be discussed here. Just see which graph is correct. You people are having the graph of what, the distance. Okay, sorry. This is the angle. The light ray are deviated from the prism. This is the angle of deviation. D is the angle of deviation. So do you know which light ray will deviated more? This is the first slide question. The deviation will take place whose wavelength will be less or frequency will be more. So if you have the high frequency, so for more frequency, deviation would increase, isn't it? So for red, deviation will be less, and for blue or violet, radiation will be more. That's why this will be the graph. So this is out of the box type question. That question is not rarely, sorry, that is not frequently asked. So here, I asked you times and again that you have to draw this splitting of light, or you have to mention splitting of light inside the prism as well. Okay, which option will be correct?
So for D, is it that like it is bending in the prism,
सारे
but is it that it's going straight from the prism and not bending
सारे
after it goes out of the prism?
सारे कुछ भी हो लेके आओ यार थोड़ा सा. Okay, sorry. Yes. Okay. Sorry, दोबारा बोलो बच्चे.
I was saying that for the D option, is it wrong because the colors are opposite, or is it wrong because the light is passing straight after it
Okay.
goes
Option
through the
A is
prism?
correct. Incorrect. Sorry. Option A is incorrect because the light is not split it inside. Order is correct. B is incorrect. Severely incorrect. Inside it is not properly drawn, and outside the order is reversed. This is correctly drawn inside, and correct order is being placed. That's why C is the right option. D is drawn properly, but it is mentioned that when the light is moving, or when the light passes out of the more denser to less denser, it it is not bending. Yani it is shown that it does not bend, but which is against the law of refraction, that when light moves from more denser to less denser, it will bend away from the normal. So that is the mistake in that one. Is it clear?
Yes.
So here, yeah, you can consider this question for your prisms practice. That is that there are two light rays. Yeah, I told you na that you have to remember this order. Yeah, recall this order. So what is number one? That will be red. And what is this number three and four? Two is your VIBGYOR. That's it. If you will recall this all, everything will be in your control. Is it clear to you?
Yes, sir.
Okay. So these type of questions are asked to you from the prism. Yes. What is wrong in this one?
I think yes, correct. Because
Everything is wrong here.
yeah, everything is wrong.
Everything is wrong here, right? So you have to take consideration of all what we have learned here. Which group contains only transverse waves? So in this question especially, there is a trap. Okay, just go ahead. Which option will be right?
Mm,
Yes.
Mhm.
Mm-hmm. Very good. Option B is correct. Infrared, light, and ultraviolet. Most of the time, instead of this ultraviolet, it is written ultrasound, which is a trap.
oh,
Remember this.
okay. So, but
Yes.
sound waves are also transfers, right? No, 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 no. I got
गुनाह
it.
कबीरा
No,
है ये.
no.
ठीक है. Okay, इस्तगफार बड़ा करो तुम. Okay. Now this is that question what I asked, what I told you, that you people have this entire discussion जो आप लोग कर सकते हो कि which order is missing or which is missing from here. So if you never know about the order of that, देखो ना, GXULIM. That's it. Now that's why option B is correct. बात समझ आई? Because 4 is your X-rays, right? 3 is your ultraviolet, right? 2 is your visible light, fine. And 1 is your wait. GXULIM and R. Is there something missing?
So, how did you learn these random letters?
बस ये मुझे याद हो जाते हैं. Jack Sulimer. Actually, this is I've just recalled it. Jack Sulimer. MR. R is here. Radio waves are at the end. So one is microwave. So just see that there is no other order which is correct. That's why you can consider it radio wave, but probably it would be microwave, because after infrared, micro is there, and then after micro, radio is there. Okay.
So they just excluded the microwaves.
Yes.
Okay, got it, got it.
अब देखो इस पे, the radio wave, visible light, and X-ray all are part of the radio, radio wave, light, and X-rays. So I told you it would be GXULIMR. So radio have the largest wavelength, and as we are moving towards gamma, our X wavelength decreases. That's why X-rays have the shortest wavelength, then light, and then radio wave. That's it.
Got it.
So everything what I have told you, that matters a lot. Which type of the radiation lies between the visible light and the microwave? Yes, अब बताइए. अगर आपको
Radio
जेक्सोलीमर
wave.
नहीं आएगा तो आप कैसे करोगे?
Yeah.
So that is infrared, है ना?
Yep.
That's it from this topic. So I believe that now you all are, I mean, very, gripped on the topic of your light and electromagnetic spectrum. अब हम कल वाला क्वेश्चन दोबारा पे उस पे आते हैं. I believe so. Just let me
सर
check
हम
that one out.
डिफ्रैक्शन भी करेंगे ना?
हाँ, उसी पे लेके आना चाह रहा हूँ. कल हम लोगों ने डायफ्रैक्शन, मैंने यहाँ डायफ्रैक्शन जस्ट थोड़ा सा, आई थिंक सो इट मस्ट बी हियर इन माय नोट्स हियर. जनरल प्रॉपर्टीज ऑफ द वेव्स, व्हाई इट इज नॉट. जनरल प्रॉपर्टीज ऑफ द वेव्स पे थोड़ी सी बात करना चाहूंगा, because I hope so that there was something, I don't know what happened, but something happened. That's why I just quit on the topic of, कौन सा टॉपिक पे छोड़ा था मैंने, रिपल टैंक. This all was done. This all
Yeah.
was done.
Yes, this was done.
So you've added diffraction in this, right?
I think so. That is diffraction होना चाहिए यहाँ पे. If it is not, this is the diffraction. I will add it at the end if it is not here. Maybe it is not here in the slides.
I
But
don't
diffraction.
think it's there.
Okay, ये तुमने सारा देखा है ना?
Yeah, I did. Like the
Okay,
when
I will add something at the end. Don't worry. So after that, you people would be able to attempt all the questions more properly and more effectively. Just let me add 2 points here. Add pages, insert pages, and four pages are enough. And yes. Okay. So when we talk about diffraction, diffraction is basically bending of light. Okay. Are you clear about the reflection and refraction?
yeah,
Okay. So it is bending of not only light, wave when it passes through a narrow slit, right? When it passes through a
this is what we're
narrow,
gonna write if it's like if they're asking the definition.
yes, okay.
Okay.
When it
Yeah.
passes through a narrow slit or narrow gap, you can say, and that is its speed, frequency, wavelength, everything remains unchanged. Wavelength remains unchanged. Okay. The only thing which changes is the amplitude of the wave changes, or energy of the wave changes. Amplitude or energy of the wave changes because of moving away. It, you can say, decreases rather. Okay. So that is why there is some condition for diffraction. That is, that diffraction takes place if the wavelength of the wave is comparatively equal or larger than the gap. Yani if wavelength lambda is greater than or equal to d, then diffraction is significant. I will explain it, don't worry. Significant, right? What is that d and what is this lambda? This is the slit, and if I have this barrier, and in the barrier, if we have just a wave, like there are some waves which are mm, approaching to that, this is the wavelength. So did you see that the wavelength is the distance between two crusts, two wave fronts? So this is wavelength. So this wave would bend significantly, and you have to draw the wave in this way that the wavelength would not change, but it would be curved, right? So wavelength would remain same. Wavelength will be kept as same. Is it clear?
So do we
So
measure
what
it?
is no, no, no. Just approximately. You have to draw three wavefronts. Usually it is called draw three wavefronts. This is D, this is wavelength. So here the wavelength is greater than D, so bending is more. So bending is more. Yeah, bending is greater, you can say. Is it clear to all? And
Yes.
if the gap between the barrier is larger than the wavelength, for same wavelength, this is the barrier, and if you see, the wavelength is just smaller than the gaps, so you will just bend the waves little, this way. Are you getting it? So as the gap is increasing, if the gap is more, diffraction would be less, diffraction will be decreased. So that is what I told you, that here the gap is more. What is increased here? You have increased the gap, and wavelength is comparatively smaller. So when wavelength is smaller than D, bending is least. That's it.
So what if they both are equal?
Equal. So here, this is that condition. Equal or greater than D, so you have to bend it.
Okay. And how would we know if they're equal? I mean, do we see approximately if they're equal?
Yeah, you will see approximation. uh Yani most of the times the gaps are very clear that wavelength is smaller or greater.
Oh, okay.
I will send you some of
Got
the
it.
questions from that one.
Sir, can you show that again?
Yes. आपको मैंने ग्रुप में ऐड किया बच्चे? वो
नहीं.
ओके, मैं ग्रुप में आपको ऐड भी कर लेता हूँ, और आई विल सेंड दीज ऑल इन द ग्रुप एज वेल.
अच्छा सर, हम लोग सेकंड वाला सिर्फ तब ड्रॉ करेंगे जब वो गैप ज्यादा भरी होगी वेवफ्रंट से.
या जब गैप आपका बड़ा होगा वेवलेंथ से, तो तब आपको ये वाला ड्रॉ करना है इस तरह से, छोटी छोटी बेंडिंग शो करनी है एट द एजेस. दैट्स, so these are called straight wave fronts. Okay, and these are called your circular wave fronts. Okay.
Okay
Yeah,
sir.
got it.
Yes, any question till now?
No, sir.
So I hope that now your uh, waves entire portion is completed, just sound is left. So I will complete sound by tomorrow, inshallah. Meanwhile, I will request you all to complete the topicals of your waves, so that if we have any question, we can discuss in the last two classes of the week. Then we will be having an assessment, okay,
Off.
of waves, complete section.
सर, इस महीने से हम लोग कौन कौन से टॉपिक्स करेंगे?
इंशाल्लाह एक हफ्ते में हम एक सेक्शन खत्म कर लेंगे, आई एम क्वाइट श्योर. सो इसके बाद हम लोग जाएंगे फॉर योर थर्मल. ठीक है, I will try my best, क्योंकि थर्मल से आपके क्वेश्चंस आते हैं, and you people will be able to do this. And then at the end I will go back to the general physics. General physics क्योंकि थोड़ा ज्यादा टाइम लेता है, so that